China built oil pipelines that bypass the entire ocean, and most of the world has no idea they even exist. Right now, nearly 80% of China's oil imports travel through a single narrow strait, a waterway so congested and so exposed that one naval blockade could bring the world's second-largest economy to its knees. That strait is just 1,800 feet wide at its narrowest point, roughly the length of 6 football fields. You heard that right. 6 football fields stand between China and an energy catastrophe. So China did something no country has ever attempted at this scale. It built a way around the ocean entirely. What you're about to learn isn't just an infrastructure story. It's a power play, decades in the making, and it's quietly reshaping who controls the world's energy. Here's how they did it. The Malacca Stranglehold. Picture a shipping lane so packed with oil tankers that they move almost bumper to bumper, day and night, without stopping. That's the Strait of Malacca, a narrow corridor of water squeezed between Malaysia and Indonesia, less than 2 miles wide at its tightest point. Every single day, roughly 15 million barrels of oil pass through it. And a staggering 80% of China's imported oil rides through that same bottleneck before it ever reaches Chinese soil. For years, Chinese energy planners stared at that number and felt something close to dread. Because here's what that dependency actually means. If a hostile naval force, a conflict, or even a prolonged regional crisis shut that strait down, China's refineries would start running dry within weeks. Not months, weeks. The factories would slow. The power grids would strain. The economy that feeds 1.4 billion people would begin to fracture. But the Malacca problem wasn't just about congestion or accident risk. It was about control. The United States Navy has long maintained dominance over the world's major shipping lanes. Chinese strategists knew that in any serious confrontation, Washington held a card that Beijing couldn't easily counter: the ability to choke off China's energy supply without firing a single shot on Chinese soil. That realization didn't just make Chinese leaders nervous. It became the defining strategic anxiety of the 21st century for Beijing. And it wasn't just a theoretical threat. It was a documented one. Chinese military planners had a name for it: the Malacca Dilemma. The idea that China's economic growth had created a vulnerability so severe, so geographically concentrated, that the entire nation's energy security rested on a waterway it didn't control and couldn't defend alone. But sitting with that vulnerability wasn't an option. Not for a country with ambitions as large as China's. So Beijing made a decision that would take decades and hundreds of billions of dollars to execute. It would build its way out of the trap not by challenging American naval power at sea, but by going around the ocean entirely. Pipeline by pipeline, corridor by corridor, China began constructing a land-based energy network that the world had never seen before. The first move came from an unlikely direction, not north toward Russia, not west toward Central Asia, but south through one of Southeast Asia's most politically complicated countries. The Myanmar backdoor. You wouldn't look at Myanmar on a map and immediately think energy superpower. It's a country the size of Texas, mountainous, deeply forested, and for decades isolated from global trade. But for China's energy planners, Myanmar wasn't just a neighbor, it was a backdoor, a geographic gift sitting right at the edge of the Indian Ocean, close enough to receive oil tankers from the Middle East and Africa, and just close enough to southern China to make a pipeline viable. The plan was audacious. Build a pipeline that starts at the deep-water port of Kyaukphyu on Myanmar's western coast, runs over 1,400 miles through some of the most rugged terrain in Asia, crosses mountain ranges, river valleys, and seismic fault lines, and delivers crude oil directly into Yunnan province in southwestern China. Oil that was drilled in Saudi Arabia or loaded onto tankers off the coast of Angola would now travel by sea only as far as Myanmar, then continue the rest of the journey entirely overland, skipping the Strait of Malacca completely. The engineering challenge alone was staggering. The pipeline doesn't travel through flat, cooperative terrain. It climbs through the Shan Plateau, crosses dozens of rivers, including the Irrawaddy, and cuts through regions with active fault lines capable of triggering earthquakes powerful enough to rupture steel. Engineers had to design the pipeline with expansion joints and flexible sections, specifically to absorb seismic movement without cracking. Every mile of it had to be built to survive conditions that would destroy a standard pipeline. Then came the political complexity. Myanmar at the time was governed by a military junta operating under international sanctions. Negotiating rights-of-way through villages, forests, and ethnic minority territories required deals that went far beyond standard construction contracts. Local communities were displaced. Environmental concerns were largely overridden, and the pipeline had to be physically secured against sabotage through politically unstable regions where armed ethnic groups operated just miles from the route. But this was just the beginning of the obstacles China would have to push through. When the China-Myanmar oil pipeline finally became operational in 2017, it changed the math entirely. Suddenly, up to 400,000 barrels of oil per day could flow into China through a route that bypassed every ocean choke point that had kept Chinese strategists awake at night. The Malacca Dilemma hadn't been solved, but it had been significantly weakened. And while the Myanmar pipeline was being built in the south, China was simultaneously constructing something far larger in the frozen north. Siberia's frozen pipeline. Imagine laying steel pipe through terrain where the ground itself is frozen solid for most of the year, where temperatures drop to -40 degrees Fahrenheit, and where the nearest city might be 300 miles away. That's the reality of building through Siberia, and China didn't just attempt it, it pulled it off at a scale that defies easy comprehension. The Eastern Siberia Pacific Ocean Pipeline, known as ESPO, is one of the longest oil pipelines ever constructed. It stretches over 3,000 miles from the oil fields of eastern Siberia toward the Pacific coast. But built into that system is a critical spur, the Skоворodino to Daking branch, that peels off from the main line and drives directly into northeastern China, straight into the heart of China's refinery infrastructure in Heilongjiang province. Russian crude oil, extracted from some of the coldest and most remote territory on Earth, now flows continuously into Chinese refineries without touching a single ocean. The engineering required to make this possible was unlike almost anything attempted before. Permafrost, permanently frozen ground, creates a nightmare for pipeline construction. When a steel pipe carrying warm crude oil sits on frozen ground, it transfers heat downward, which thaws the permafrost beneath it, which causes the ground to shift and sink unevenly, which bends and stresses the pipe until it fails. Engineers solved this by elevating sections of the pipeline on refrigerated supports that actively kept the ground beneath frozen. In some stretches, they buried the pipe deeper than standard to stay below the active thaw layer. Every solution created a new engineering problem that required another solution. Then came the most brutal challenge of all, the Amur River crossing. The pipeline had to pass beneath one of the longest rivers in Asia, in a region where winter ice pressure could crush standard infrastructure. The crossing required horizontal directional drilling deep beneath the riverbed, threading steel casing through solid rock hundreds of feet below the surface, then pulling the pipeline through. It took specialized equipment, months of work, and engineering precision measured in fractions of an inch. But the payoff was transformational. When the ESPO spur became fully operational, it locked in a supply of Russian crude that now delivers over 600,000 barrels per day into China. No tankers, no straits, no exposure to naval pressure. And it did something else that no one fully appreciated at the time. It bound Russia and China into an energy relationship so deep and so infrastructurally entrenched that it would prove almost impossible to unwind. And that relationship would matter enormously when the world's energy map was about to be redrawn from an entirely different direction. The vast, landlocked steppes of Central Asia, Kazakhstan's invisible energy highway. You've probably never heard of Atasu. It's a small city sitting in the middle of the Kazakh steppe, flat, windswept, and almost completely unremarkable to the outside world. But underneath and around it flows one of the most strategically significant pipelines China has ever built. The Kazakhstan-China oil pipeline, stretching over 1,700 miles from the Caspian Basin all the way to Alashankou on China's western border, turned a landlocked Central Asian nation into one of China's most critical energy corridors. The setup here is almost poetic in its simplicity. Kazakhstan sits on top of enormous oil reserves, billions of barrels locked beneath its steppes and its share of the Caspian seabed. For decades, the only way to get that oil to global markets ran through Russian territory, which meant Kazakhstan's energy exports were effectively filtered through Moscow. Russia controlled the pipes, and therefore controlled the leverage. China saw that arrangement and recognized an opportunity not just to access Kazakh oil, but to give Kazakhstan an alternative route that bypassed Russia entirely. That offer changed everything. Suddenly, Kazakhstan had a second option, and China had a pipeline stretching from the heart of Central Asia directly into Xinjiang, delivering crude oil that never once touched a coastline or crossed a maritime choke point. But the engineering challenge here wasn't frozen ground or seismic fault lines. It was sheer distance across some of the most desolate terrain on the planet. The pipeline crosses the vast emptiness of the Kazakh steppe, pushes through the Dzungarian Gate, a narrow, wind-blasted corridor between mountain ranges that has historically been one of the only land passages between Central Asia and China, and then descends into China's Xinjiang region. Pumping stations had to be built roughly every 60 to 90 miles along the route just to maintain enough pressure to keep oil moving across that distance. Each station is essentially a mini industrial facility operating in near total isolation, monitored remotely and maintained by rotating crews in conditions that most engineers would consider extreme. Then came the tension that no pipeline map can fully capture. Xinjiang, where the oil arrives, is one of the most heavily monitored and politically sensitive regions in China. Running a critical energy artery through it meant the pipeline security infrastructure had to be woven into an already complex web of surveillance, military presence, and regional control. The pipeline didn't just cross a province, it crossed a geopolitical fault line. But China absorbed that complexity without hesitation, because the payoff was too valuable to pass up. The Kazakhstan pipeline now delivers roughly 240,000 barrels per day into China, and it anchored something far larger, a Central Asian energy web that would soon expand to include Turkmenistan, Uzbekistan, and beyond. And once you see all three pipelines together on a map, Myanmar in the south, Siberia in the north, Kazakhstan in the west, you start to realize that China wasn't just solving an energy problem. It was building something that had never existed before, engineering the impossible network step. Back from the individual pipelines for a moment, and look at what China actually built. Thousands of miles of steel running through deserts, mountain ranges, permafrost, river crossings, seismic zones, and politically volatile territories, all of it designed to move oil continuously, every hour of every day, without interruption. The scale of engineering required to make that happen isn't just impressive, it's almost incomprehensible. Start with the pumping stations. Oil doesn't flow through a pipeline the way water flows downhill. It has to be pushed constantly, forcefully, and precisely. A pipeline spanning hundreds or thousands of miles requires pumping stations positioned at regular intervals, each one capable of generating enough pressure to keep viscous crude moving through steel pipe against friction. Elevation changes and temperature-driven viscosity shifts. On the Kazakhstan pipeline alone, there are over a dozen major pumping stations. On the ESPO system, the number climbs even higher. Each station runs around the clock, staffed or remotely monitored, and connected to backup power systems, because a single prolonged failure doesn't just slow the oil, it stops it. And stopped oil in a cold climate pipeline can congeal into a nightmare that takes days to clear. Then, there's the monitoring infrastructure. Every major pipeline in China's network runs on SCADA systems, supervisory control and data acquisition, essentially a nervous system of sensors, pressure gauges, flow meters, and automated shutoff valves that spans the entire length of the pipe. These systems can detect a pressure anomaly consistent with a leak within minutes, automatically isolate the affected segment, and alert response teams before the situation becomes catastrophic. In remote terrain where a rupture could go unnoticed for days without this technology, SCADA isn't optional, it's what makes the entire network viable. But this was just the beginning of what it takes to keep these pipelines alive. Physical security along routes passing through politically unstable regions requires agreements, patrols, and sometimes entire security forces dedicated to pipeline protection. In Myanmar, Sections of the pipeline run through territories where ethnic armed organizations operate. In Kazakhstan, the route passes through regions with histories of unrest. China's solution wasn't just to build fences, it was to build relationships, economic dependencies, and in some cases direct security partnerships with host governments that tied their own stability to the pipeline's continued operation. The pipeline didn't just carry oil, it carried leverage, and underneath all of it runs a maintenance cycle that never ends. Pipe inspection vehicles called smart pigs are regularly launched through the pipeline to crawl the interior, scanning for corrosion, wall thinning, weld defects, and structural anomalies that could precede a failure. Catching a problem at the inspection stage costs millions. Missing it costs infinitely more. What China built isn't just a collection of pipes. It's a living, breathing industrial organism that requires constant attention to survive, and China built the capacity to sustain it indefinitely. But keeping oil flowing was only half the equation. The other half was making sure no one could take that flow away. The power beneath the pipes. Here's what most people miss when they look at China's pipeline network on a map. They see infrastructure. What they should see is strategy, decades of calculated moves designed to answer a single question. How do you make yourself impossible to starve? Every pipeline China built does something beyond moving oil. It creates a relationship. When China runs a pipeline through Myanmar, Myanmar becomes economically dependent on the transit fees, the construction investment, and the ongoing operational spending that comes with it. When China builds a route that gives Kazakhstan independence from Russian export infrastructure, Kazakhstan owes China something that goes beyond a commercial contract. When Russian crude flows through a dedicated spur into Chinese refineries, Russia and China become bound together by infrastructure that neither side can easily abandon without causing themselves serious economic pain. China didn't just buy oil. It bought loyalty, dependency, and geographic positioning all at once. And then there's what these pipelines do to the leverage that once kept Chinese strategists awake at night. The United States Navy's ability to pressure China through energy disruption was always rooted in one assumption that China's oil had to travel by sea. Every barrel that now moves overland is a barrel that no naval blockade can intercept. At current capacity, China's overland pipelines can move over 1 million barrels per day into the country through routes completely immune to maritime pressure. That number is still a fraction of China's total import needs, but it's a fraction that grows every year, and it represents a strategic buffer that simply didn't exist 20 years ago. But the implications stretch further than China's own borders. When oil that once traveled by tanker through the Indian Ocean and the South China Sea instead moves through a pipeline, that's freight volume removed from global shipping lanes. That's tanker demand that evaporates. That's port traffic that shifts. Global oil logistics were built over a century around the assumption that crude moves by sea. China is methodically challenging that assumption not through conflict, but through construction. Then came the realization that hit energy analysts hardest. China's pipeline network doesn't just serve China. It anchors an entire continental energy architecture that stretches from the Persian Gulf to Siberia to the Caspian Sea, all feeding into a single destination through routes that Beijing controls, influences, or has deeply embedded relationships with. That's not a pipeline network. That's a parallel global energy system running alongside the ocean-based one the rest of the world depends on. And while the world was watching China's naval buildup, its technology sector, and its trade disputes, China was quietly laying the pipes that may matter more than any of it. Because at the end of the day, the country that controls how energy moves, controls how the world moves, and China just built itself a network that the ocean can't touch. One grid, one strategy. Pull up a map of Asia and trace the routes. A pipeline cutting south through Myanmar's mountains to the Bay of Bengal. Another driving north through Siberian permafrost from Russia's eastern oil fields. A third pushing west across the Kazakh steppe through the Dzungarian Gate. 3 completely separate projects built over 2 decades across 3 different countries in 3 completely different geographic and political environments. But when you draw them all together and watch where they terminate, something clicks into place. Every single one of them ends inside China. And together, They form something no single pipeline ever could, a continental energy grid that stretches across the largest landmass on Earth. This wasn't accidental. Chinese planners didn't build these pipelines in isolation and discover later that they connected. The connectivity was the point. Each pipeline was a deliberate node in a network designed from the beginning to give China overland access to every major oil-producing region within reach, Russia's Siberian fields, Kazakhstan's Caspian reserves, and via Myanmar, the Middle Eastern and African tankers that could now offload at a friendly port instead of sailing all the way around to Shanghai. The network didn't just diversify China's supply routes. It built a web of infrastructure-based alliances that no diplomatic agreement alone could replicate. And then Belt and Road arrived and supercharged everything. China's sweeping Global Infrastructure Initiative, which has now touched over 140 countries, shares the same fundamental logic as the pipeline network. Build the infrastructure, and the relationship follows. Finance a port, a road, a railway, or a refinery in a partner country, and that country's economic interests become quietly aligned with China's continued presence. The pipelines were Belt and Road before Belt and Road had a name. They were the proof of concept that showed Beijing exactly how infrastructure could be weaponized as diplomacy. But this was just the beginning of how deep the strategy actually runs, because each pipeline also solved a political equation that money alone couldn't buy. When Kazakhstan ships oil east through Chinese infrastructure, it needs that relationship to function. When Myanmar collects transit fees on every barrel that flows through Kyaukpyu, its government has a direct financial stake in China's energy security. When Russia's eastern oil fields are tied to Chinese refineries through a dedicated spur, Moscow's energy calculus shifts accordingly. China didn't just build pipelines. It built a series of mutual dependencies so deeply embedded in physical infrastructure that unwinding them would cause serious economic pain to every party involved except China. That's not infrastructure. That's architecture. And it's reshaping the world's energy map in ways that most people are only beginning to understand. The world can't ignore this. For over a century, global oil moved in one direction toward the nearest port, onto a tanker, and across the ocean to wherever it was needed. The entire architecture of global energy logistics, the tanker fleets, the port infrastructure, the shipping insurance markets, the naval patrol routes, was built on that single assumption. China is now systematically dismantling it, one pipeline at a time, and the consequences are rippling outward in ways that touch every major player in the global energy system. Start with the tankers. Every barrel of oil that moves through a pipeline is a barrel that doesn't need a ship. As China's overland capacity grows, the demand for certain tanker routes softens. Shipping companies that built their business models around the assumption of permanent, growing Chinese demand for maritime oil transport are quietly watching volumes shift. It's not a collapse, not yet, but it's a directional change that the industry can feel. And in global commodities, directional changes have a way of accelerating faster than anyone expects. Then there's the naval dimension, and this is where it gets uncomfortable for everyone else. American strategic dominance in the Pacific has always rested partly on one quiet threat: the ability to squeeze shipping lanes and make an adversary feel the weight of ocean-based vulnerability. Every overland kilometer China completes makes that threat weaker. A pipeline buried under a Myanmar mountain range or threaded beneath the Amur River cannot be stopped by an aircraft carrier. That's a fundamental shift in the geography of power, and other nations are watching. India, Russia, Central Asia. Everyone is now asking the same question China asked 30 years ago. What China proved is brutal in its simplicity. The ocean is optional. China just stopped depending on it.